What's up everybody, welcome back. So we're going to continue our Lyra WeaponFX mini-series, and today we're going to add our impact FX and also the impact damage numbers. So we're going to take a look at how to set everything up and make sure everything works in multiplayer as well. One little thing I would like to mention, you can now join the channel and become a member. If you do so, you will get access to premium channels in the Discord and a nice membership badge. And you can also just join the Discord for free if you don't become a member, and you can ask questions about the video or show a project that you created or just talk about some game dev stuff. So that's all announcement I got for you today. Let's dive into the video. So before we start working on our blueprint, I would like to take a quick look at the Lyra Startergame to see how they set it up, and that way it makes a little bit more sense to see what I'm doing and why I'm not exactly doing what they did. So over here is the weapon impacts blueprint from the Lyra Startergame, and this is the event that gets called when a weapon is fired, and all of the arrays will be populated with the impact positions and things like that. So first they call a function to sort the impact arrays, and what this does, it will sort the impact arrays. So let me try to explain. If I would shoot at an enemy with a shotgun and that enemy would stand in front of a wall and that wall has a window in it, so let's say a few pellets of my shotgun hit the enemy, a few hit the concrete wall, and a few hit the glass surface. So then an array of impact surfaces will return, and all of them could be scattered around. So let's say my shotgun has 8 pellets. This could be the array of impact surfaces that could return. So what they do in this function is they are going to sort the array by impact surfaces. So after it's sorted, it looks like this. So they have default, then 2 body, 3 concrete and 2 glass. But they do not only sort it by type, but they also make sure it's sorted from low to high corresponding to the enumeration of the surface types. So what I explained in the previous video, the surface types are an enumeration. We can convert an enumeration to an integer, and that way we can make sure that we look up the correct values. So they create new arrays in this function as well, one called number of impacts and one called start offset. And the arrays that would be created in this case would look like this. So the number of impacts for my impact surface 0, which would be default, is 1. So there's 1 impact surface for default, and the start offset is 0 because it starts at index 0. Then for the second index, it has 2 numbers of impacts for the number 1, that's body impacts, and it will start at index 1. So over here you see index 1 and then 2 body impacts, and so on and so on. So for the second enumeration index, which would be concrete, there's 3 impacts and it starts at index 3. So it would be these 3. So that's what this function is doing, and in the end it will return everything back into the same 3 arrays that were put into this function. So they have the impact normals, impact positions and impact surface types. But this time these are organized. So let's dive back into the event graph. Then they grab a for each loop and they check how many surface types they have. They convert that surface type to an integer, like I mentioned with the enumeration. And then they simply use a selector over here to determine if they have the correct Niagara system available or not. So these are simply variables stored on the blueprint, and you can see on the left side over here, the right side, I'm sorry. So we have impact glass for the glass, and then concrete has concrete, and the character and default have no impacts set up. So they handle the character impacts in another place, and for default are no impacts. So they check if they have a correct impact system for Niagara. If they don't, they are not going to do anything. So they stop executing here and go back to the for each loop. And if they do, they actually spawn a new system, check some distances and things like that, and then they're gonna put the impact system in an impact system array, store it. So it's kind of overcomplicated as far as I'm concerned, mainly because we only have 2 or 3 impact surfaces to deal with. And the reason they put it back into the arrays with the offsets and the number of impacts is because they simply pass on the entire array of impacts into each impact system. So over here, for example, they only spawn the concrete impacts, but they plug in the entire array with all of the impacts, and that is simply tell the start offset and the number of impacts to the Niagara system, so the Niagara system knows what indexes to use and what to ignore. So I kind of understand what they are doing, and it's all pretty nice and cool to set up this way, but it's kind of overcomplicated to look at. And since we only have 2 or 3 impact surfaces, if we simply set it up by splitting the arrays, it would not take a whole lot more work. So I'm going to keep the same principle, but I'm not going to make it as complicated as it is over here. So that was my tiny explanation. Let's dive into creating the blueprint. And we're going to create the blueprint for our impact affixes. So create a new blueprint actor and call it BP WeaponFX or Weapon Impact. Sorry. And let's open it up. So again, the first thing we're going to do is make sure it replicates. So class defaults and enable the replicates flag over here. And then we are ready to go into the event graph, and we're going to get rid of all of this and create our new custom event. And that's weapon fired. So let's make sure that we set this up as a multicast event, and then we can set the rest up. So first let's plug in some inputs. We're going to need our impact positions. And that's an array of vectors. So vector and turn it into an array. Then we need our impact normals. And that's also a vector array, so that's good. Then we need the impact surfaces. Impact surfaces. So we need an array of physical surfaces. Physical surface. And the last one we need is our muzzle position. And that's a single vector. So vector and then single. So those are good to go. Again, we're going to promote these to a variable like we did in the previous episode. So do that for all of them and store them right away at the beginning. So that's good to go. Now I'm going to create a new function to split the arrays into different arrays for each surface type. So I'm not going to sort them like they did in the Lyra game. I'm simply going to split them up and have a separate array for each of them. So to make that happen, I'm going to copy the impact positions and the impact normals a couple of times and rename them. So first of all, I'm going to need an array for the body impacts. So I'm going to call this, well, let's call it body impacts. A vector array, that's fine. And then I also need body normals. So I'm going to change the name, body normals, vector array. And then we also need concrete impacts and concrete normals. Concrete impacts, concrete normals. And the last one, the glass impacts and the glass normals. There we go. Let's set these up first. So we're going to create a new function and call this split arrays by surface. Split arrays by surface. And let me see. I'm going to grab my notes here quickly so I'm not messing up. So we're going to grab a for each loop and we're going to plug in our impact array. So grab the impact surfaces array over here. And we can simply compare them. So first of all, I'm going to drag off the array element and I want to say equal to enum. So if this is a default surface type, we do not need it. And since most of the default of the surface types are probably default, we're going to check this first. And if this is true, we are not going to do anything. So we're simply going to stop there. If this is false, we're going to add a branch, plug it in, and simply compare it to the next surface type. So let's drag off here again, and we're going to check if this might be body. So that's equal to enum. And if this is body, we're going to store them in the body arrays. So then we can simply drag in our body impacts and our body normals. And we can grab an add node. for both of them, and then plug in the array element. So if this is true, and then we simply, let me see, we want to plug in the index from the impact positions array and the normals array. So we're going to grab our impact positions over here. Let's do it down here. And then impact normals as well. And we're going to get a copy for both of them. And use the index from the for each loop to plug it in over here. And then that's the element we want to add to our body impacts array. So plug it in like this. So if this is not a body surface type, then we can continue checking for the next one. So hook this up to the false pin, and we're simply going to check if this is concrete. So plug it in over here is concrete, and if it is, we can add it to our concrete array. So we can do the same thing as we did here. So let's copy and paste it over here. Plug this into the true pin. So let's replace these with our concrete arrays. So concrete impacts and concrete normals. And make sure that we grab the index from the each loop. And that should be good. And then the last thing we need to do is check for the glass surface type. So again, let's copy all of this and paste it over here. Hook it up to the false pin, and let's grab our surface type. So if this is glass, we want to add them to the glass arrays. So glass impacts and glass normals. And grab the index from the for each loop again. And that's good to go. So now we end up with 3 different arrays with just a single impact surface in each of those arrays. So it's a little bit less advanced than the Lyra setup, but it will still work fine. So we're going to drag the function in over here and split the arrays by surface. And then we're going to grab a sequence node. So drag off here, sequence. And the first thing we're going to spawn is the concrete decals. So let's drag off here and let's grab a branch first. So branch. And we want to check if we actually have concrete impacts. So let's drag the concrete impacts in here, and we're going to check is not empty. And hook it up to the branch. So if it's not empty, we want to spawn the system. So we're going to spawn a system at location. Spawn system at location. And now we want to spawn it at the concrete impacts position. So let's grab concrete impacts. And drag off here and do get a copy. And we're simply going to get the first index in the array and plug it into the location, and that's good to go. So we want to make sure auto destroy, that's all good to go. So we can promote this to a variable, and this is my Niagara system concrete impacts. So let's just do concrete, why not? And then we can set it up at the beginning over here. So let's add a little bit more room, drag in our concrete system, check if this is valid. So this should be hooked up to the true pin. If it's not valid, we're going to spawn one. And then we also want to check if it's active. So is active. And grab a boolean or a branch, sorry. Plug it into the condition, and if this is false, we're also going to spawn a new system. Now we want to make sure that if this is true, that we update the world location of the system to make sure that all of the sprites and decals turn up in the correct angle. So what we need to do is drag off our concrete system over here, and if this is true, we're going to set the world location. Plug this into the true pin, and we can simply grab the concrete impacts index 0 and plug it in here. That should be good to go. And now we can set the parameters on the system. So let's drag it in over here. And first we need to set our position array. So set position array. Hook this up to both of the execution pins. And we can simply grab our concrete impacts and plug it in over here. And for the actual name, that's user impact positions. So over here, and let me show you on my notepad. So that's user impact positions. I'm going to leave it over here, okay. The next thing we need to do is set the vector array of normals. So drag off here again, set vector array, and we're going to plug in the concrete normals. And for the name, that's user impact normals. So I'm going to paste it over here and then show you guys impact normals. The next thing we need to set are the number of hits. So we can drag off the system again and set an int 32. Int 32. Grab this one. And this time we're going to grab our concrete impacts array and set get the length from here. So don't type get, just length. And then plug it into the in value. And the name is user.number of hits. So where is my notepad? Oh, really? Over here. So user number of hits. And what do we have next? We have our muzzle position left, and then we can activate it. So let's drag off the concrete system again, and we're going to set a position. Set Niagara position variable. Plug it in. Grab our muzzle position from the variables, and that's our user muzzle position. User muzzle position. Grab my notepad over here, so this one, and then we can activate the system. So we don't have a trigger for this system. I'm not quite sure why, but it's just not here. So we're going to drag off here and simply activate. And that should work. So that's the concrete branch. And now we can do the same thing for our glass branch. So let's simply copy all of this stuff and paste it below here. And let's start at the beginning. So let's hook it up to the sequence. Now we need our glass impacts over here. So let's replace this array. Then we want to get rid of the concrete reference over here and over here and over here and the last one over here. So we're going to change the system to the actual glass system. So impact glass. Oh, I was afraid it was going to crash on me, but it's probably compiling shaders or something. So a little hiccup. Okay, we're back. So let's promote this to a variable, Niagara system glass. And then we can make sure we plug it in at the beginning to the isValid node and also to the isActive node. And we need to make sure that we replace this concrete with a glass impact. And if we move on over here, we need to make sure that we replace everything as well. So first let's drag in the Niagara glass system and plug it into all of the nodes over here. So that's the target for all of them. There we go. And now we can simply replace the arrays. So this is the glass impacts, glass normals, glass impacts, muzzle position is fine, and activate is the same as well. So over here we should be good to go. Now I didn't actually set up the concrete Niagara system over here. So spawn system at location. We need to make sure that we set up our concrete system, otherwise nothing will happen. So that should be good as well. And now let's do the last one, and that's for our body impacts. So let's go to our sequence, let's add another pin, and we want to grab this branch and paste it over here, plug it into the last pin. So we're going to check if our body impacts array is not empty, and this Niagara system works a little bit different because it can only spawn one impact. Although it does have the parameters for the arrays, it doesn't seem to work. So I'm not sure if I'm missing something or it's just really not working like that. But what we are going to do is simply grab a for each loop over here. And we're gonna plug in our body impacts into the for each loop. And let me see, then we're gonna spawn a system at location. So drag off here, spawn system at location. And the system we want to spawn is our body impact sparks. Or character impacts, whatever. Sparks, that is. And let me see, we want to spawn it at the array location. So we're simply going to drag the array element directly into the location. And for the rotation, we can get the body normals. So we can drag in our body normals array. We can get a certain index. So get and plug the index into the for each loop. And then we can plug this into the rotation and that will convert it for us. So that should work as well. Now we're not going to store this as a variable or anything, just make sure that it's auto destroy. So if it's done, it will delete itself. With that done, we only have one thing left, and that's the damage numbers. And to make sure those work, we need to add one variable over here, and that's our owning player. So if we display the damage numbers, we only want the actual player that shot to see the numbers and not the other players, because that looks a little bit weird. So we're going to make sure that we pass on the owning player as a variable. So this is your hero character. So in my case, that's my hero base. And that's that's a hero base variable. We need to make sure this is instance editable, exposed on spawn, and also set to replicate. So with that in place, we can go to the end of the for each loop over here, and we're going to grab a branch, plug this in over here, and we simply want to check if our owning player is locally controlled. So drag the owning player in, and we're going to check if this is locally controlled. Locally controlled over here. And we can plug this into the condition. So we're only going to spawn the damage number fx for local players. And then we can set it up. So let's grab a spawn system at location. Nope. Spawn system at location. So we're going to spawn our damage numbers. So that's the first one in the list over here. And we're going to grab our body impacts array and get the first index. So get a copy and plug that into the spawn location. Rotation, we don't need to set it up. The rest of the settings over here are good. So let's promote this to a variable and call this Niagara damage numbers. No. So with the variable in place, we can place our isValid check at the beginning here. So we're going to drag in our Niagara system damage numbers and check if this is valid. We need to hook this up to the true pin. So if we are a local player, we're going to execute this. And then again, we want to check if we are active or not. So is active, and grab a wrench over here as well. So if we are not valid or if we are not active, we're going to spawn a new one, and otherwise we're going to set the world location again. So let's drag off the damage numbers over here, and we're going to set world location. Plug it into the true pin, and for the location we can use the body impacts 0 index. So drag it in over here. And now we need to set up the parameters. So we are going to drag in our damage numbers system over here, and we're going to set a vector4 array. Vector4 array. Plug this in over here. And we also need to, well, we don't need to do that. Let me see. So first of all, let's grab the name. So we want the override name to be user damage info. And let me grab my notepad. So we have user damage info. And then we're going to work on the array in a little bit. We could add one extra node over here, and that's set Niagara variable bool. And we're going to take a look at this a little bit later. So first of all, for the damage info, we have a vector var array. And if I would drag off here and I would say make array, and then I would simply make a vector. So it's simply a vector with 4 values in here. And the way this is set up, the first 3 are simply the coordinates of the fx. So that's the impact location. And the last one is the amount of damage that will return as a number. So what we could do in this case is go back to the for each loop over here. And we're going to create a new variable in here. And that's our damage info. And we're going to turn this into a vector var array. So look for vector var and then turn it into an array. And then we can make a little bit of room in between here. And we're going to grab our damage info array and set an array element. Hook this up to the loop body, plug this back into the spawn system at location. And now we want to grab the index from the loop body and we want to split the item over here. So split struct pin. And then we're also going to split the vector that comes from the for each loop. So drag off the array element and we can break the vector. So now we can plug in the location just like this. And for the damage, for now, I'm simply going to plug in a number. So I'm going to show you in a little bit how you could set this up to your weapon. So let's say random int, random integer in range. And I'm just going to use something like in between 8 and 12 and plug that in here. So we actually see something happening. So now for each body impact, it will add an impact to the damage info array, and we can simply pass the damage info array on here, and that should be good. So if you would like to call this when you actually hit a character, then the best thing you could do is simply separate this branch over here and then create a new custom event and use the damage amount as an input for that event, and then you can call that event from your player if you hit a character, and that should display the damage number. So that's really not too hard to make that happen, and for now I'm simply going to use it like this so we can see it's working. So over here we do need to make sure that we set it to size to fit, and then I think we are good to go. So let's compile and save this. Is not a self. So I forgot to hook up a pin somewhere, set world location. This needs to be hooked into the glass system. And then we are good to go. So let's go to our character blueprint and let's dive into the weapon fired function, because over here we want to spawn our new blueprint. So let me see. We're simply going to do the same thing. Let me grab my notes. Okay, yes, we're going to do the same thing as we did previously. So we can, let's just add a pin over here and grab a spawn actor. So we're going to spawn our impacts, VP weapon impacts, and we need to make sure that we assign our owning player. So that's the variable that we exposed on spawn, and we need to hook this up with a self node, otherwise it's not working. And now we can promote this to a variable, so make sure that you actually have a spawn transform hooked up, and then promote to variable. So that's our BP weapon impacts, and then we want to attach it to a component. So we are an actor, so actor to component. And we're going to attach it to our weapon mesh again. So drag in your weapon mesh component and plug that in over here. And with that done, we can simply call the weapon fired. So we can drag in our weapon impacts over here and call weapon fired. And all we need to do is plug in the rest of our variables. We can hook this up in a little bit. So these are local variables. And those are actually the same as this one. So let's paste them over here. Impact positions, impact normals, surface types, and the muzzle position. So the reason I'm using a separate blueprint for the decals is because these have a much longer lifetime than the MuzzleFlash. Otherwise they would have used the same variable, so it would have made sense to put them on the same blueprint, but since these exist for 10 or more seconds and these only for like half a second, it makes a little bit more sense to split them up. So we can grab our weapon impacts over here and check if this is valid. And then we can hook this up over here. If it's valid, we're simply gonna call it. So hook that up to the weapon fired and hook this back up to the sequence. And then I think we should be good to go. So what we could do is make sure that our impacts array is not empty in case we shot into the air or something. So we could grab a branch over here, plug this in here, hook the true pin into our isValid node, and then we want to check if our impact positions array is not empty. And hook that up over here. Okay, with all of that set up, the only thing left is go back to our switch weapon event. And if we switch a weapon, we want to make sure that we also set our weapon impact blueprint back to undefined. So that way it will spawn a new one with the correct values and let this one die out and remove itself. So I think this is good to go. Let's have a little look. First I'm going to save everything because sometimes it tends to crash a little bit. And here we go, multiplayer host, multiplayer search. So we should have 3 different impact affixes according to our impact surfaces, which would be concrete, glass, and the body impact. So let's have a look over here. There we go, it was compiling shaders, I think. Okay, so I know what I forgot. But other than that, I think it's working. So if this would spawn our body impacts, you cannot see it really good, but it's spawning. I'm seeing a lot of sparks over here. So let me go back and make a little fix. So first of all, let's open the weapon impacts. And we want to grab another pin in our sequence over here. And we simply want to make sure that we clean up all the arrays. So we need to make sure they are empty if we come back in here for the second time. Otherwise we keep spawning those affixes. So that's mainly for these arrays for muzzle position, not muzzle position, sorry, body impacts, body normals, concrete impacts, concrete normals, glass impacts, glass normals, and our damage info. So for all of these we need to make sure that we clear them so they are ready to go for the next time we run into this blueprint. There we go. Now hook everything up. And plug this into the sequence node. There we go. Okay, so the other arrays are automatically overwritten by default, so that doesn't really matter. So what's it whining about now? No value will be returned by reference parameter impact normals. Okay, because this is so annoying. And turn it back into a vector, compile, hook it back up. So you're satisfied? Okay, then I'm satisfied as well. Fine, so we have the arrays cleared and now this should work a little bit better. We do need to make sure that we also clean the blueprint up if all of the systems have become inactive. So let's add that branch as well and then we are done for today. So let's drag off a new pin on the sequence node and look for a retriggerable delay again. So this is going to be a 3-second delay and then I'm simply going to check all of the systems that are on this blueprint. So we have concrete, glass and damage numbers. And I want to know if they are valid. Nope. And then I'm simply going to grab an OR loop, an OR bool. And we can plug in all 3 of them. And if any of these are still valid, then we're going to loop again and wait another 3 seconds. And otherwise we're going to get rid of the blueprint entirely. So plug this into a branch. And if this is true, we want to loop back. So let's go over here. And if it's false, we can simply destroy the blueprint. Destroy actor. And that's good to go as well. So now we are ready to go. So host a game, multiplayer search game. So let's join it and start the game. So I'm going to move to the back of the wall to make sure you can see the FX a little bit better. So I can see impact FX for the glass spawning over here. Oh, get lost. And then we have concrete impacts over here. And we have body sparks with damage numbers over here. So that's working. Now let me grab the host. And let me get rid of these guys. So again, I'm firing and I can see my impacts on both screens. And if I fire over here, only the host see the damage numbers and the client doesn't see anything. And we also have impact FX for glass. So everything is working and we have the impact FX and damage numbers ready to go. So the only thing left is the MetaSounds, I think. So we're going to take a look at that in the next episode. For today, thanks for watching everybody. Hope you enjoyed the video. If you did, please consider leaving a like and I'll be back soon for more. Later.